Hello everyone, welcome to Code Enzyme. So in this video, let's again solve this same problem using a new technique, and this technique is called Mohs algorithm. So let's first read the problem statement again. You are given an array of n integers. Your task is to process q queries of the form what is the sum of the values in the range a to b. And again, if you do a for loop from L to R, it will give you a TLE because that will be a big of n square time. And since we have 2 into 10 to the power 5 elements, you have to do this in big of at least big of n log n time or n root n time. Okay, yeah. So let's first discuss what is Mohs algorithm. So in this case, like what do we have? We have some L to R queries, like what is the sum of in the range L to R, right? So what Mohs algorithm says is that what we can do is uh, we can first store the queries like in the LR fashion, an array of L to R, like L1 R1, L2 R2. Okay, okay, then L3 R3. Now let's say these are in some random order, right? First what we can do is we can sort, since we already know these queries, we can try solving these queries first in an order such that we are able to solve this in n root n time. And once we solve these queries, we can print them in any order that we want. So what we can do is we can first solve these in an order such that first what I'm going to do is I'm going to sort these by the left values. So let's say L1 and R1, like if these two are closest, then I will solve the L3 R3 queries first and then L2 R2. Okay, so like what is happening is that let's say we have a big array. Okay, so let's say I have divided this in some blocks, like this block and this block and this block and this block, like just like we did in the previous video. So first I'm going to divide this whole array into some blocks, and now I am going to sort these arrays by their block number. Like if some query is in from a block of a bigger index, then I am going to process that query later. And if they belong to the same index, like let's say we have a query L1 and R1, and then L2 is somewhere from here to here. Okay, so I just need to increase my left pointer to the right and this to the right in the same block. So this will happen in big of square root of n time, right? Okay, so now that we have this, that this is happening in square root of n time, uh, what I need to do is like first of all I'm going to sort these L and R values by their block number, and if they are in the same block, I need to do this, like I need to shift the pointers and then calculate the answer. It is actually very simple to understand now. Obviously it will take you a little bit more time than the square root decomposition because we are not skipping the blocks, we have to increment these pointers, but it will run in overall big of n root n time. Now it might be pretty hard to understand in theory, so let's just dive into the implementation part. Okay, okay, so now we will try implementing the Mohs algorithm. And so let's first take the input, that is first we have int n and q, cn n and q, and vector int a of n, array of size n. Then let's take the input array. Okay, now since we want to process the queries first, we need some way to store the queries. So I want to actually create a vector of these queries. So what I like to do is I like to create a struct. So let's have a struct of, let's call it queries, and it will have a left index and right index, and also an index. So let's just name it idx. You can call it ind also, doesn't really matter. And now let's create a vector. So vector of queries of, let's call it queries only, of size q, and let's just take the input. So int l and r, or maybe I can just directly say queries I dot left, queries I dot right, right? And obviously since these will be obviously since I want to store the zero based indexing only, what I want to do is I just want to do queries I dot left minus minus. Why am I getting these errors? Oh, it is because it is because these values should be comma and not like this. So right and index. Okay. So now all the errors are gone, and now I can say queries I dot right minus minus and queries I dot idx equals to I. Okay. So now I have taken the input, and now I want to sort these queries. So by the block, right? So first thing I can do is let's first set the block size. Okay. So once you have the block size, I can define a custom comparator function. So let's say compare, and it will take two of the queries as input, and then we will compare. So let's say const, you can skip the const, but yeah, or you can even put it queries and b, and now we want to compare it. So first thing I should get is the block number of these two queries. So let's say int block a is equals to a dot left upon block size, int block b is equals to b dot left upon block size. And now if these two blocks are different, then I can simply sort them by their block numbers. So if block a not equals to block b, then what I can do is I can simply sort them by the block number. So return block a is less than block b, right? Yeah. Otherwise, if these two are similar, then I can sort them by the right indices. Now what is recommended is when you should try to alternate them. Like if the blocks are odd, then you should try to sort them by ascending, and if they are even, then you can try it by descending, or any of these two way, but it should be alternating, and that will eventually helps you minimize the number of left and right steps. That is what is observed. So what I'm going to do is, let's say block a and 1. So if this is the case, then I will try to sort them by one of the orders. So let's say a dot right is greater than b dot right, or you can also go with left, perfectly fine. Otherwise a dot right less than b dot right. So both will work. Okay. So now that we have the compare function, let's try to sort these queries. So how will you sort them? You can simply use your sort method. First of all, let's initialize the block size equals to square root of n. Once you have the block size, you can try sorting it. So let's say sort queries dot begin comma queries dot end and compare. Okay, so this will sort your queries in the proper order, and after this you can try what we have to do is we have to find the sum, right? And we have to answer the query. So let's say vector int answer of size q, because there are q queries, and now I will initialize three variables, that is the current sum equals to, let's say it is a of 0, and current left is equals to 0, and current right is equals to 0. Okay, so this is like the base case where you currently the current sum is the first element, and the left and right are like that. Now let's for loop. now let's loop in the queries. So let's say for queries q in let's actually make it a reference queries. And now what I need to first get the L value, that is let's make it capital L. L equals to q dot left and int r is equals to q dot right. Okay, now if the current left was more to the left of this let's first process the left part only. Okay, Okay, so why is this happening? Process the left part, and for this what I'm going to do is, like, while the current left is already let's say if the current left was greater than this L. Okay, so what I need to do is I need to go more left. So I will say, like, okay, current left minus equals to 1, and current answer or current sum plus equals to A of current left, right? So we will keep doing this. If initially my current left was to the was not that much left, and similarly sorry about that. Okay, now similarly what I can do is, let's paste it again. If the currently the left index was more to already more to the left side, so what I need to do is I need to bring this to the top, and initially I will do minus equals to, and here I will do plus equals to. So basically I will do in the reverse of this part. Okay, and similarly what I can do the reverse of this for the right index. So I will say, like, current right, what is happening. So if current right is okay, so if the current right is like, okay, let's say greater than, so R, so what I'm going to do is I'm going to, like, say if current right was already more to the right, then I should shift this line to the top first, and once this is done, then I should say, like, minus equals to current underscore right, and like current underscore right plus equals to 1. And once this is done, I think I will just write it on my own instead of copy pasting. So while current right is less than R, if it was not, so I need to move to the right, so current right plus plus, and current sum plus equals to A of current right. And once this is done, I can set the answer of the query. So answer of q dot idx equals to current sum. And once you are done, you are basically, you have solved your queries in the good order. And now you can simply print your answer, right? So for int answer in answer, let's say cout answer handle. And now when we try to run this, I think I made some mistake. Yeah. Okay. Let's try running this. And okay, we are getting an infinite loop. Why is that? If current left is, wait a second, if current right is greater than R, so it is already greater than R, so I should do minus equals to 1. And if current right is less than equals to R, less than R, then yeah, okay, so that was the error. And now okay, and I think this is the correct output now. Let's try to submit this again and see if it works. Okay, so our solution got accepted, and as you can see, it took us a little bit more time than the square root decomposition, and obviously more time than the segment tree. Okay, but yeah, it is one of the algorithms you can use, and it is quite simple, I think. And if you were able to understand this, kindly like this video, and in the next question we will move on to the next problem, that is the static range minimum queries. Thank you for watching. Okay.